method so that we'll have this stored permanently. So I'll send you the link so you could rewatch it as of tomorrow. It will be posted on YouTube. All right. So let's go. First question says factorize completely. All right. So let's focus on this question here. I'll rewrite it just here. It says 4a squared minus 16. All right. So 4a squared minus 16. What you must do at all times whenever you're factorizing is that you try to look for a common factor first. If there is no common factor, then there are a few levels of factorization that we could focus on. But currently, I'm seeing that 4 is a common factor right now. So because 4 is a common factor, I am going to factorize out the 4 first to see what's going on. For example, 4 is common, so I'll take out the 4, I'll open my bracket. And if you don't remember how to factorize, whenever you take out the common factor, you're going to divide that common factor back into the terms. For example, you will say 4 into 4a square, and the 4 cancel itself, so you can see the a square comes back. You will say 4 into the 16, 4 into itself 1, 4 into 16 4, so you see that minus 4 comes right there. That's what really happens. Now some people might think that this is finished. It's not finished, because when they say factorize completely, you have to go to the end, meaning when you look inside here, you would definitely see that this is a special type of factorization. It is called the difference of two squares, meaning a is square and 4 is a square number. How do we know that 4 is a square number? 2 times 2 gives you 4. So 4 is a special number. It's a square number. Whenever you have the difference of 2 squared, though, it's a very easy factorization. All you have to do is to open 2 brackets, and you're going to look for the square root of a square and the square root of 4 and put them in the bracket. For example, the square root of a square is a. You put a here again. This one is this simple. The square root of 4 is 2. You put 2 there, and then you put 2 there again. Technically, it's the same things you'll have in the 2 bracket, except you'll put a plus in one and then a minus in one. So this is what they wanted to see. You will get 2 marks for this. 1 mark is to take out the 4, and the other mark is to do these. So that's how you would have gotten the 2 marks. All right, so this one is kind of special. It's the difference of 2 square that came out for of that, and it's for 2 marks. All right, the second one here says 3y squared plus 2y minus 8. We want to factorize this. But in trying to factorize this, we definitely realize that, hey, I don't see anything in common. Like y is not common because there is no y attached to the 8. And there is no number that could go into 3 and 2 and 8 apart from number 1 without a remainder. So this means that we can't factorize by the highest common factor. Definitely, we're going to have to use the AC method. So it's our responsibility to take out A, which is the coefficient of the square. So it is number 3. B, which is the coefficient of just the y, which is number 2. And C, which is the constant, the number without any letter attached to it. And it's not 8, it is negative 8. Bear in mind, we're doing the AC method, which means that we need to know what is AC. AC means A times C. So let's look. The A value is 3. The C value is negative 8. So when you put this together, you will get negative 24. Now, whenever you're factorizing by the AC method, when you find this number here, you're going to have to go on a little mission. The mission is that we want 2 numbers that when you add them, they give us 2. And when you multiply those numbers, they give us back 24. Now, the good thing is those numbers can go into 24 without a remainder. So then we are advised to list the factor pairs of 24. What do I mean? Things that can multiply to give 24. Let's list them. 1 times 24. 2
and 12.
12. 3
4 and 6.
times, yes, 3 times 8. 4 times 6. That's it. So you're going to observe these to see which one of these pair could add or subtract to give a 2. You can realize that, oh, it's 6 and the 4 that could give us a 2. Remember though, one of them will be positive and one will be negative. Let the bigger one take any sign B has. B is positive 2, so the 6 is positive and the 4 is negative. So we're going to be using these two numbers here. All right. The other numbers could not work because we can't get a 2 by adding or subtracting those. We can't get a 2 there. We can't get a 2 there. We can only get a 2 from this one. And that is why we use them. So let's set it up now to go. 3y squared plus 6y. The two numbers we find will go in the middle and it will take on the y term, this term. So 3y squared plus 6y minus 4y minus 8. So this is where we are right now. If you notice, we have 4 terms dealing with. Let's check them off. 1, 2, 3, 4. The moment you find yourself with 4 terms and there is nothing common for all, you have to factorize by grouping them. So we're going to be grouping these two, and then we're going to be grouping these two. What is common for the first group? Anybody want to suggest? This is group 1. What's common for group 1?
3 and y.
3y. Very good, class. 3y. So what you're going to do now is to take the 3y and divide it back into the term. So 3y into 3y to the second, we're left with y. And 3y into 6y, we're left with 2. Close it. Go to the next group. What is common is negative 4. So negative 4 into negative 4y, we're left with y. And negative 4 into negative 8, we're left with positive 2. Whenever you're factorizing and you reach the stage where you're seeing the same thing twice, you know that you're on a right path. So what we're going to do, we're going to separate. We're going to separate the common thing. And you see the two things on the outside? Look, this is one and this is another. They are on the outside. They will go in the last bracket. Look, 3y minus 4. And this is what they wanted you to do to get 2 marks. So this is factorizing by the AC method. We were doing this in September of the school year, right? All right, good. Now, another thing that comes at number 2 is a simultaneous equation. As you could see, we have x and we have y. Normally, you will be solving like one variable. But now, we're actually solving 2 variables. 2 variables. Give me 1 second, guys. 1 second. 1 second. Let me respond to a call. All right, guys, give me 1 minute. Let me send a message here. This is very important. I have to make a quick call to somebody. All right? Won't take long.
Yes, sir. Dear thing.
Yeah, man. Give me 1 second. I just need to call home. Mute your mic. Mute your mic. Sounds like chat. So I'm calling my home. Just give me a second.
No.
All right, just give me a second. I won't take long. In the meantime, let's look. EJ, Oh, in a session, somebody will come up here to me. Just look out for one car here, and you can deal with them. All right, let's go. All right, let's go. All right, so now we are going to start off this problem by eliminating, right? We have to eliminate one of the variables because as you could see, we have two variables. We can't solve the equation with both of them in it at the same time. So it is our responsibility to get rid of one of them. So what we're going to do, you select which one you want to get rid of. I want to get rid of the y. Yeah, I want to get rid of the y. So because I want to get rid of the y, I'm going to be picking on the number that is attached to the y's. For example, even though this is not here, I'm going to write it. There's a number 1 in front of that, and there is a number 2 in front of the other one. So let's call this equation 1. Let's call this equation 2. What we're going to do is that we're going to take the numbers that are attached to them here, and we're going to interchange them. Number 1 is up in equation 1. I'm going to use it down by equation 2. Number 2 here is in equation 2. I'm going to use it up by equation 1. All right. So let me take off that. All right, good. So this is how we deal with these things. You take the thing that you want to get rid of and you flip it. So the number from the top, you put it on the bottom, and the number from the bottom, we put it by the top. What we're going to do is to create 2 more equations. So we're going to multiply all of this by number 2, and we're going to multiply all of that by number 1. So we'll get number 3 and number 4 after. So let us go for number 3. This 2 here, let me color it yellow. We're going to use it to multiply by this, then this, then this. So let's do that. 2 times 2x will give us 4x. 2 times 1y, or just y, will give us 2y. 2 times 3 will give us 6. So this is equation 3. We're done with that. Now we're going to be using we're going to be using number 1 in green to multiply by 5x, then negative 2y, then 12. Let's go. 1 times 5x gives us 5x. 1 times negative 2y gives us negative 2y. 1 times 12 gives us 12. This is equation 4. Now, the aim is that we intend to eliminate. Whenever you do this trick, you're going to realize that you get back the same number. Check it out. So whenever you do that trick, you will always get back the same number. Sometimes the sign is different. If you notice, there's a positive here and then there's a negative here. So you'll ask yourself this question. If I have a positive 2 and a negative 2, what do I do so they disappear? Do I add? Do I subtract? I would suggest that you add them. Because if you add a positive and a negative of the same, it gives you 0. So you could put it on your calculator and you'll see that you'll get a 0. That means it disappears. The y has been eliminated. So then what we're about to do is just to add. We are going to add equation 3 and 4. You could write it. You don't get marks to write it, but I'm writing it for your sake. So we're adding equation 3 and equation 4. We're adding them. So you would see then that some people draw a line here, understand? Or some people write it. It doesn't matter how you want to do it, just add them. All right? So we could say, all right, let us say we join the line. All right? So you draw the line and we're just going to put the value there. So let's go. So let me remove that. So we say we're going to be adding them already. Draw the line. Watch. 4x plus 5x, 9x. This part cancel and become 0 because it's a negative and positive of the same number. Fine. Equal 18. Now we're going to be solving for x. So we need to divide by 9, and watch this. 9 into itself 1, 9 into 18 2, x equal 2. We are at half of the journey because we have a value for x. X is equal to 2. What we could do now, since we know that x is equal to 2, we could substitute this value in any one of these equations, anyone, and find the other thing. What do I mean? Watch. Now, let me mark off here just to give us right here. So I'm going to do it underneath here. So I'm going to just say, since x is equal to 2, then we could use the simpler one. Like the top one looks way simpler because the top one just says 2x plus y equal 3. What we want to do is to substitute x equal 2 right here. So we're going to put 2 where x is. So we'll have 2 times x, but it is now times 2, this 2, plus y, and this equal to 3. Let's look. This is saying 4 plus y is equal to 3. We're almost done, because if I subtract 4 from both sides, we will see that y is equal to -1. So here it is, y is -1. Normally, you don't have to, but for conclusion, we say x is equal to 2 and y is equal to -1. And that's how these things are, all right? That's how it is most times. All right, so that's a regular simultaneous equation that comes in section 2. And look at that, look at this. Look how much marks this thing is for. Check it out. Do you see that? You see how much marks you get for this? That's a lot of marks, you know. That's a lot of marks. So even though a lot of people might think, oh, it's a lot of work, I love this question because it's a lot of marks you get for it. So it is just a simultaneous equation and you are good to go, 5 marks, just like that. Now, there are other things that come at number 2. And you're going to see the various things. This one is a topic called variation. Variation. That one is a topic called variation. Now, there are 2 types of variation. One is a direct variation. One is called an inverse variation. But you could see that they would tell you which one you're dealing with. See there? Direct variation. So when I solve this problem, you're going to see how variations are developed. It's not like I'm teaching it now so that I could sit and teach. I'm just solving the problem. So I'll read it and then I'll set it up and I'll try to explain as best as possible. It says the table below shows corresponding values of the variables x and y. I'm right here. Where y varies directly as x. This is the key instruction. Y varies directly as x, which means that whenever you're doing a variation question, there is a formula that will tell what ought to be done. And this is it. They gave us, they say y varies directly. Whenever you hear that something varies directly, you write the thing, put equal, put a k, and then put the other thing. So this is saying y is equal to kx. Now you might ask, where does the k come from? The k is what we call a constant. It is in every variation. It's something that they will not tell you about most times, but it is in every variation. Let me just give a quick understanding of what variation kind of look like. Every single day you would have been walking through the town of Mapen and you will experience some persons selling juice. And so you notice that if you're going to try to buy a juice, most times you ask how much for one. That's the K you're asking about. You're asking how much for one. Like I said, juicy, how much one are your juice? Because you expect that it will remain that one price all the time. And the price does not normally change. So how much for one? Him said $30. I say, all right, give me 2. So you're going to pay $60. So the amount that you buy and the amount that you pay will be changing because somebody else was walking by and they said, how much I want? Him still say $30. Them say, what? Give me 10. So then they ask for 10 and they pay $300. So with the direct variation, the more you get, the other thing go up. So when one variable go up, the other variable go up. So in this case, if the X increase, the Y will increase. So that's why it's called direct variation. In other times, maybe we could go deeper, but I'm just trying to answer the question. So we'll set up Y equal to KX. Now, calculate the values of T and U. In order to calculate the values of T and U, you need to know the constant. Just as though, in order to pay the man and to know how many bag juice you can afford, you will definitely need to know how much I want. So we can use this column to find out that case where you'll know the value for K. Because this case happened already where X was 6 when Y was 3. We can substitute those. X was 6 when Y was 3. And if we substitute those right here, we will know the value for K. Check it out. So we're saying Y is equal to KX. Y is 3. So 3 is equal to KX. And KX means K times X times 6. We're almost there. We want to find a value for K. Let's put it up. K is equal to, divide both sides by 6. You could see, bam. The K is now alone. And K is equal to 3 over 6. But we'll normally break this down. 3 into itself 1 time, 3 into that 2 times. So K is equal to 1 over 2. K is a half. Some people use 0.5. No problem. So we're saying that K is a half. Now, the variation questions are like this. When you know K is the constant. You know what the word constant means? It means that it will not change. So when X changes to 10 and Y will change to another number, K will be a half. When Y changes to 9 and X changes to another number, K still remains as a half, and that is why it is called the constant. All right? This topic comes every year. I see a variation question popping up. So what we're going to do now is to use the formula for variation now and solve for U. Watch this. Remember that Y is equal to KX all the time until this question is finished. Now you know that K is 0.5, or you can use a half. Now you know that X is 10 right here. So X is 10. But if you ask me what Y is, I don't know. They said it is called U, and they say, can you find the value? No problem. So in other words, then Y is U. So all we need to do is to find a value for U. So I'm going to put the U where Y is, so that at the end of the day, I'll get U equal. That's fine. Let's look at it. Now, Y is equal to KX. Now, Y is called U, so I'm going to put U is equal to KX, but K is 0.5 and X is 10. Look how easily we find U. U is equal to a half of 10, which is 5. Done. So U is 5. We're done with that, you know. But I feel like it getting harder. It does not get any harder. So it's just a system that we have to understand. Let me move this for a second. All right. Now, let's go and find T. Now, you'll notice T is in the X line. Check it out. Follow the X row, T is in it. So that means right now, let me borrow off this so that you could see what we're doing. X is called T, and they ask us to find it because we don't know it yet. Question mark. But if you look below it, you'll notice that you have the value for the Y. Oh, Y is 9. And guess what? The constant remain at a half. So while everybody is changing, you know, if you notice, you know, X and Y no stop change. K, the constant, cannot change. If you want to remember again, just think about this. The man who has sell the bag juice, $30, $30. People come and buy a lot. Some people buy less. It changes how much money he collects from you. So those are changing, but the price for the bag juice remain. That's like this man here. does not change. Let's work this out. Y is equal to kx. Y is 9. 9 is equal to k times x, but x is what? X is called t. So that's it. Now let's divide both sides by a half. Divide this by a half, and you're going to realize that 18 is equal to t. Or some people might say t is equal to 18. So at the end of the day, we did solve what they want. 1, u is equal to 5. T is equal to 18. And that is a variation question. We might see another one, and you're going to realize the flow is going to be the same. All right. Remember that you have the recording to watch over. So I'm imploring you to start researching. Remember, the exam is May 11th. So I'm saying start researching, man. Start watching stuff, watching YouTube, watch questions, go and research questions and watch and start learning. All right. Now you're seeing the variety again. Look at, this is another number 2. All right. So on this number 2, hold on. Let me see if I see the total. No, I'm not. Okay. On this number 2 here, you're noticing one thing. There it is. We have some things to simplify. So there is a mixability in terms of the question, but you will see the exact questions that come here. We solve algebra, we factorize, we do variation, we solve inequalities, we factorize, we solve linear, we do algebra fraction right at number 2 only. All right. So look at this one now. This is something we might have learned very early, like grade 8, grade 9, we're multiplying terms. Now, what's the rule when you're multiplying terms? When you multiply letters that are the same, you add their powers. That's the thing. When you multiply letters that are the same, you add their powers. For example, we're multiplying p to the 3rd, q to the 2nd times p, q to the 5th. So there's p and there's q. Definitely, we're multiplying. Check it out. We are multiplying. So then it's going to be p and q, but we have a p to the 3rd, see it here, and then we have a p to the 1. If you don't see a power, it's 1. Don't think it is 0. So we're going to put plus 1, because when the letters are the same, you add their powers. Please remember. Look at the q. We have q to the 2nd at the front, and then we have to the 5 after that. So we're adding those. The final response I'm expecting is p to the 4th, q to the 7th. And this is what they want you to give for your 2 marks. How you feel about that? Anybody? You can just say something. Good to go? All right.
Yes, sir.
All right, number 2B. 2B, right here. Again, you see right here, algebra fraction, this. Now, what is an algebra fraction? It's a fraction that has a letter in it, that's all. So you're seeing, it's not about just numbers, we're seeing A in it as a letter, and we are asked to do this. It says, express as a single fraction in its lowest form. So we're going to go for that. I'll say to you though, please approach these problems just as how you approach any problem. We are adding fractions. When you add fractions, you focus on the denominator. So the question is, do I have the same denominator? And the answer is no, we don't have the same denominator, because we're looking at 3 and we're looking at 2. If you're adding fractions and the denominators are different, you need an LCM. Definitely the LCM of 3 and 2 is 6. The LCM is a number that the denominator could go into without leaving any remainder. So then we're seeing where 3 into the 6 goes 2 times. So the 2 will be multiplied by anything on top of the 3. Same principle. 3 into the 6, 2 times. And that 2 comes up here. All right, let me remove that. Get off. All right. Then now we're going to say 2 into the 6. That's going to be 3 times. 3 times 3a. So then, here is the deal. So we're looking at 2 times a up there. That will give us the 2a right there. And 3 times 3a will give us positive 9a. Now, together, we're talking about 2a and 9a. That's 11a, and it is over 6. It does not get harder, and it does not get easier. It's just what you do. So that's the final answer. All right. All right, so in an effort to look at the other one, I will definitely I'll definitely do it to the side because there was no space on the paper that year. So I'm going to do some of these to the side. So I'm at C. C says factorize completely. X squared minus 5x plus 4. Again, this is the factorization that we have been doing. So we're going to have to write out what is A. A is 1. How do I know? We don't write 1 in front of a letter. So if you don't see a number in front of it, it's a 1. B is negative 5 this time. Negative. Can you see that? And C is 4. We need to know what is AC. So it's 1 times 4. And this is 4. There are 2 numbers that can go into 4, that when you multiply them, you will get 4, and when you add them, you'll get 5. So when you look, 1 times 4 give 4, 2 times 2 give 4. This is the pair that can give me a 5. 2 and 2 can't give 5. But a 4 and a 1 could give a 5. Now, I have to put negative 1 and then negative 4. So that when I multiply negative 1 times negative 4, I get positive 4. And if I add negative 1 plus negative 4, I get negative 5, which is what I want right here. So then, I will be using negative 2, negative 1, and negative 4 to solve this problem. So you'll have x squared, negative 1x. This does x, but you know, for people to feel comfortable, negative 4x plus 4. So that's what we have right now. So then, you have 4 things. You have to group up these and group up that. For this group, x is common. Open the bracket. X into x squared, x. X into negative 1x is negative 1. Negative 4 is my common thing on this side here. So negative 4 into negative 4x will give me positive x. And negative 4 into positive 4 will give me negative 1. At the end of doing your AC factorization, you have to look out for the fact that you expect a twin bracket. Now, since you have seen the twin bracket, then you could just write back one of them. And again, I'll say this to you. I said it before. The things on the outside, check it out. They will go in the other bracket at the back. x minus 4. You're done. So it's the same thing again like the one we did on the previous paper, and it comes a lot. Any question?
Sir,
Go ahead.
you have to put the variables that are outside at the back?
No.
Okay.
It could have been written like this. It could have been written like this. You could have placed these out front and put the other things at the back. It's mathematics, so it doesn't matter. The main thing is that you have them like that, x minus 4 and x minus 1. That's the main thing. So it doesn't matter which one of the bracket comes first, okay?
Okay, sir.
So that is correct as well. Good question, because some people might think it is wrong. It's not. All right, going further, we have m squared minus 4n squared. If you observe these, you definitely realize that, hey, I'm seeing square, square, square. And that's why there's a topic in factorization called the difference of two squares. And you should notice that you're seeing square, square. 4 is also a square. So you can say that, oh, this is the difference, and difference means to subtract. So we're seeing where two square things are being subtracted. So here's the deal. Whenever you have the difference of two square, most times it's a 1 mark question, honestly. Most times it's 1 mark. Most you'll get is 2, because it's not a lot of work you have to do, all right? I'll say to you, know the square root. So you'll open 2 brackets when you get this type. You notice when I'm doing the AC method, I don't open the brackets. I work it down because there is something to work out, and unless you can think up it quickly. But definitely with the difference of 2 square is only the square root you're going to put in here. For example, square root of m square is m. Since the m was at the front, put it at the front. You have to. The square root of 4n to the second is going to give you 2n and give you 2n again. Again, this is done. You just need to put a plus, then a minus. And you get your marks. So with the difference of 2 square, you should notice that it is the same things that are in the bracket. The only difference is that there is a plus in one, and then there's going to be a minus in the other. So those are some stuff that we have to just quickly, look at when we're handling our business. All right. All right. Not bad. Not bad. Not bad. So those 2 factorizations, see them over here. They give you 2 marks for one, and then they give another 2 for one. This is the examiner. These are things that come on the exam. And that is why I said, if you guys are serious, you can get some marks, but you have to be serious. Let's look at the D part of the question. So let's look at the D part. It says solve for x. And I think I'm going to push that up there in the corner, and then I'm going to put the question down here. So I'm looking at the D question, right? The D question right here. The D question says 2x minus 7 is less than or equal to 3. I would say to you that when a lot of people actually see this, they think it's a difficult task. It's not. There is what we call an inequality there. It's called an inequality because it's not an equation. So it's an inequation because of this symbol right there. Do not think that you do anything special. There's only one thing that you normally do special, but it's worked out normally, just very normal. So let us see how normal this could be. Watch. This is how normal it is. Your objective is to solve for x. So you're going to isolate anything that is directly attached to the x for last and the x. So we're leaving that. But we definitely will try to get rid of the 7. We will add 7 to the left side and add 7 to the right side for balancing. When you do that, you definitely know that these two things here cancel out themselves. So we have 2x less than or equal to 10. 2x less than or equal to 10. Then now, in order to find x, then you would have to divide by 2. Why? 2 is multiply. To cancel something that's multiplying, you divide by it. So you divide by 2, you balance the equation by dividing the other side by 2. So you could see now 2 into itself, fully canceled, 2 into itself, 1 time, 2 into the 10, 5. Let's write down the solution. The solution says x is less than or equal to 5. I want you to listen to what we are saying. X is less than or equal to. Again, x is less than or equal to 5. So that means this question is saying the values for this, they are less than 5 or at least is 5. So like 5, 4.999994 going down 3.99999 whatever to 3 to 2 to 1, and it goes on going down like that. So those are the solution for that. But for now, this is how it is represented. And you notice you really didn't do anything, special. You just work out the math, and this was where it ended. Normally, they will give you some follow-up questions. So you could see here that x is less than or equal to 5 was the response. Normally, how much for that? About 2? 1. So they give it, hold on, guys. This thing is moving. All right, there. All right, so we get 1 mark for that there. So you could see, so they are saying that this is no biggie, quick 1 mark. So they are saying, watch this now. If x is a positive integer, you see that? Very important piece of information. We'll talk about this right now. If x is a positive integer, list the possible values of x. If x is a positive integer, what is an integer? Anybody want to tell me what is an integer quickly? What is an integer? Anybody remembers what is an integer? Anybody? Going once, going twice. An integer is a number without decimal or fraction attached to it. You could just leave it at that. So an integer will be your counting numbers, all right? So your counting numbers and the negative of the counting numbers along with 0. Or you could say all numbers and the negative of the whole numbers. That's it. But the question don't want the negative ones. This time it says if x is positive. So then we should be able to list the possible numbers here. First one is 5, 4, 3, 2, 1. Because they said if x is a positive integer, list the possible values of x. Remember, this question told us that x is less than or equal to 5, which means we're looking for values less than or equal to 5, but they must be integer and they have to be positive. And we're saying these are the positive integers. They are just regular counting numbers. And if you notice, they don't think it's a big work because they give you 1 mark, because they're saying everybody who does math knows those numbers. All right, not bad. All right, let's migrate to here. And you could see number 2 at the time comes for, I think it's about 9 marks now. We'll check it when we see another question. All right, it says find the value of 2 pi times the square root of L over G when you're given all of these. Pi is this, L is that, G is that. So they wanted to find the value of this. It's testing to see if you can substitute. So this question is really going back to your grade 9. Can you substitute? Yes, you can. So it's going to be representing these. So let me write it first. 2 pi, and then we have the square root of L over G. 2 pi, 2 pi means 2 times pi. Pi is 3.14. 3.14. So we just did the 2 pi part. Then they're saying that this will multiply by the square root of L, which is 0.625 over G, which is 10. No biggie. All we have to do is to take our time and work out these on our calculator. So we're going to do that. 2 times 3.14 is 6.28 times the square root of this. Because when you divide this number by 10, you'll get 0.0625. Because when you divide by 10, the decimal point shift to the left. But you don't need to do that. You just have your calculators and you put it on it. 0.625, and you divide that by 10, and you'll see the point I'm making. Now, what we want to do is to carry out this final information. You can put all of this on your calculator. 6.28 times the square root of 0.0625, and you will get 1.57, and you're done. That is the answer. I trust that you guys are following and putting these things on your calculator, because remember, Anna, me are the maths, you know? So I'm expecting you all to work out your stuff as we go along. Work along with me. We're not doing this question. It's a number 3, if you notice. So I think it was not, it should have been cropped off. We're only doing
What if
number
we
2s.
just put everything in our calculator and put down the answer?
Talk to me.
What if we just put everything in the calculator and put down the answer? We have to show working out.
Yeah, man. Yeah, man. The first thing CXC says is this: all working must be clearly shown. That's the biggest instruction on the front. So they want to know that you never copy, because some people can peep over at the exam and just write off an answer, but it is harder to write off a lot of steps. Not true. So you kind of show them that you did your own work when you show the progress of your answer. Here, it shows that you did your work, because people do copy and they are skeptical about that. So that's you proving to them that, listen, me know me I do. All right, now we're at another number 2. Look, it's another one, and check this out. So now you start seeing things coming back. We did an algebra fraction already, and they're giving us a different type. So it means that those are the things that come at this question. Let's go through it. Again, you could see that, let me rewrite it for us. So we have a 2x plus 3 all over 3. And then we're adding this to x minus 4 all over 4. Definitely you're seeing that the denominators, they're not the same. And we're adding again. So if you're adding and the denominators are not the same, you need to find your LCM. What number can 3 and 4 go into without a remainder? The class will say 12.
12.
Yes, and then we go through that process by saying 3 into 12 goes 4 times. 3 into 12, 4 times. That number 4 will go to multiply by the thing that is on top of the 3, like that. So you could carry out the multiplication. If you notice, there's a double thing up here. It's not one thing. So you're going to have to use the 4 to go with them. For example, 4 times 2x will give us 8x. 4 times 3 will give us 12. Then we're over this side. This 4 will divide into the 12. And 4 into 12, everybody will say 3. That number 3 will be used to multiply by everything that is on top, meaning it's going to go with the x and the -4. 3 times x will give you positive 3x. 3 times -4 will give you -12. So now we want to group up like terms here. There are like terms on top. For example, 8x and 3x are friends. Positive 12 and -12 are friends. So let us just finalize them. I'm just writing the step for your sake. See there? Grouping them, you would definitely see that the answer is 11x over 12, because positive 12 and -12 gone. So this is the answer. All right. So we did another algebra fraction. So you see what's going on?
Yes, sir.
Yes, I'm listening. Go ahead, Chrisan.
Sir, you just say yes, sir.
Okay. All right, look at this one now. So there's another type come now. We said, write the following statement as an algebraic expression. So sometimes they are going to give statements and they want you to write it using algebraic expression. So you have to read it. And some of these things you have been doing since you're in grade 6. Read it and you see. For example, it says, the sum of a number and its multiplicative inverse is 5 times the number. No, that sounds like a lot. Now, whenever you get any situation like this, it says the sum of a number, you can just name your number. Rome, you're marking up the board, Rome. Rome? I don't know if it's a Jerome. You're marking up the board and it won't come off unless you take it off, and I don't want to start over the board. Jerome? See if you can undo that, because it's going to stay there even when we move. See there? Even when I move, your markings will be there until the session over. I can't take it off. All right, so if you can get it off, that will be good. All right, let's move, because I don't want to start over the board, honestly. All right, let's go. So I'm going to have to ignore it. All right, so we have this. So it says the sum of a number and its multiplicative inverse. I guess I would have to talk about this. So it's not the sum is my issue. We're talking about the sum of a number. Let's call the number x. Let's call the number y. Let's call the number p. I don't want to use x. I'm tired of it. So we're going to use the number. So I'm going to say, let's call the number p. So I'm going to call the number p. All right, so you don't have to write this either to say, let's call the number p. No, I am doing that for the class. So let's call the number p. So the question says, the sum of a number p and its multiplicative inverse. P. You know what the multiplicative inverse of p is? When you say inverse, you flip something. So p can be seen as p over 1. We know that. So imagine that you flip this, you get inverse. So you'll get 1 over p. So the inverse of p is 1 over p. Now, they did say the sum of a number and its multiplicative inverse. Now, you could see that these two things are the reverse, or what we call the inverse of each other. But they say the sum of them. That means you need to put a plus sign between them. So it says the sum of a number p and its multiplicative inverse. So this part is good. Is 5 times. When you say is, it's like equal. When you say is, it means equal. Think about it. The sum of a number and its multiplicative inverse is. That means it's equal to 5 times the number. Remember, the number is p. 5p. And that's what they just said. The sum of a number and its multiplicative inverse is 5 times the number, 5p. So it's a nice little talk session. You're talking to self and you're trying to see what they're saying. That's what they wanted you to write. You were not asked to solve it or anything, and you get 2 marks to do that. Anybody feel all right looking at that? Can you relate to it? Anybody? Okay. All right, we're going further. Again, look at that. Factorization come. And then when you look at this one, anybody wants to tell me which type of factorization we're looking at right here? Anybody? We have x squared minus 36. Anybody wants to identify what type of factorization is that?
Difference of 2 squares, sir.
Yep, it's the difference of 2 squares. How do we know? You know because x is squared and you have to have a little number in your system. 36 is a result of 6 times 6. X is a result of x times x. So definitely it's a difference of 2 square things. All you have to do whenever you see this, and I believe this one is for 1 mark. Let me look. 2 marks again, I'm going to give you marks. So you open 2 brackets when you have this type. All you're going to put is the square root in it. What is the square root of x squared? X. And since the x was in front, you have to put it in front 2 times. What is the square root of 36? It is 6. And you put 6. And then you can put a plus and then a minus. And if you feel like you want to put the minus first, it's all right. So let me tell you what I mean. If you did it and you do this, you're still all right. Because sometimes people feel funny about stuff. You can put a minus and then I put a plus after. It's the same answer. So if you want to do it like that or do it like that, fine. But that's what you have to do to get the marks. If you get 2 marks for it, I guess they're going to give you 1 to do that and give you the next one to do that. I saw them work. So that means some people will pick up one out of the 2. Look again and see if you're not seeing the concepts being repeated now. All right. Now you're seeing that, okay, factorization is a big deal for number 2 because see, come back here. And again, this one is going to be the AC method. So as you could see, we need to list out our A, our B, and our C. A is 2. A comes right in front of the square. B is 5. B just come in front of the x, as in the 5 comes in front of the x. C, -12. It's just the number without any letter. AC means 2 times -12. And we saw this number sometime. Here it is again, under a different context now. 24. What are the possible things that multiply to give 24? You have to list them out. 1 times 24. 2 times 12. 3 times 8. 4 times 6. So these are the possible pairs that can multiply to give 24. It means then that one of these pairs will answer our question. So you have to ask yourself, which one of these pairs I can get a 5 out of? Definitely I can't get 5 here, so I can't get 5. I can't get 5, but I can get 5 there. So you're seeing where we can get 5 there, because a 3 and a 8 can give a 5. Now, remember, when your AC is negative, like -24, one of your number will be positive and one will be negative. Let the bigger one take any sign B has. B is positive right now, so 8 is positive, 3 is negative. And that's the way to go. Let us plug them in. 2x squared plus 8x minus 3x minus 12. Now, every single time you come up with those 2 numbers, they will go in the middle of the other 2. And they will take on the variable for the middle. If you notice, it was a 5x right there. They're taking on that. And if you really subtract the 3 from the 8, you will see that it's like you still have the same thing. So it's a way to split it up into 4 so that we can factorize by grouping. Now, what's common here is a 2x. So 2x into 2x to the second, we're left with x. 2x into 8x, you're left with 4. -3. -3 into the 3, -3x, you're left with x. And -3 into the -12 is +4. So Chad, I'm going to do it your way now. These 2 things here, they must go in a bracket by themselves. So if you want to put them in front, it's okay. 2x minus 3. The other twin, see it here, twin. You notice you always get this twin. You just write down any one of the twins in the other bracket. So whether you want to put this out front and then this after, or you want to put this out front, then this after, it's fine. But this is the answer for the marks. Any questions on that? All right. All right, so that's a factorization thing going on there. All right, so outside of the factorization now comes what is called transposition of formula, basically making something the subject are solving. It says here, the formula for the volume of a cylinder is V is equal to pi r square h. No problem. They are saying make R the subject. When something is made the subject, what happens to it is that it is by itself. Now, currently, the subject of this formula is V. They ask us to make R the subject. I don't even have R in this case. I have R square. But if I can get R square by itself, I'll know what to do to get R. Now, I'll give us a little hint. Whenever you're solving or whenever you're transposing, if you want to cancel anything, you have to do the inverse. So if you know the inverse of these things, you're good. The inverse of adding is to subtract. The inverse of subtracting is to add. The inverse of multiplying is to divide. The inverse of dividing is to multiply. The inverse of a square root is to square something, like square something. And the inverse of a square is to take the square root of something. So those are ideas that you use to cancel things. Let us start. If I want to find R, then it's my responsibility to isolate the R. But I'm not going to move the R. I could get rid of the pi and the h. Watch. The pi and the h are multiplying. So I'm going to draw a line and I'm going to put them underneath. So I'm going to do the inverse of what they are doing. And they will cancel themselves out. Watch. H cancel itself. Pi cancel itself. The thing is, whatever you do on one side has to be done on the other side. So we have to draw a line on the other side. And then we divide it by pi and h. I want you to understand that in mathematics, nothing is really gone. It might be missing from this side, but you'll see it on the other side, stuff like that. So then let's rewrite this. V over pi h is equal to r squared. We're not done. We're not done because they didn't ask us for r squared. We were asked to find r, but we are at r squared. We need to get rid of the square. What do we do?
Square root.
Thank you very much. We'll take the square root. So then you could see now we're going to take the square root here, but whatever you do on one side, you have to do it to the other side. So we take the square root of the other side. At the end of the day, we could just write this, that the square root of v over is equal to r. All right, that's the answer. That's the answer. The square root of v over pi h is equal to r, just like that. So this was just a quick lesson in terms of how do you get rid of things, because you notice that the pi and the h were multiplying. We got rid of them by dividing. We did the opposite of multiplication and they canceled. We realized that the r had a square on it, and this is what we did. See there? We did that so that it cancels off that. So in transposing, we just have to remember that the inverse operation is what will help you. I guess some more will come where we'll exercise our knowledge one more time. All right, let's go again. Let's go. All right. All right. This one here, I think I'm going to have to put it to the side. Like, yeah. So we're going to do that one Here, so let me read what it says before I shift it. When you see a problem like this, I'm begging you, do not just look at it and run, because I realize when people see this, they just look at it. They look at it and they run off. Now, don't do that, because I believe that you can do it. All right. So if I say you can do it, you can do it. No.
Sir.
Yes, go ahead.
Sir, you're not taking the arrows off the screen.
I can't take them off. Somebody named Rome put it on the screen. And that's what I was saying, guys. I can't, like when you mark the screen, I can't take it off. You know? You have to take it off. So anybody with this name, R-O-M-E. I don't know if it is Jerome Knight, but the person's name was Rome. When I was seeing it was marking, they were the one that probably uncapped something, but I can't take it off. And if you notice, when I'm shifting my screen, it stocks. So Rome would have to do that. Or, all right, you want me to close the board and reopen it? Because that's the only way it can go. If Rome, well, let me try. It's still there. And I don't want to come out of Microsoft. I don't want to come out of this because you notice it's still here. Rome, you have to take it off. Because if I try to close this, it may not open, and I don't want to risk that.
Sir, take care, sir.
You mark on the board that you have to undo it, I know. I uncatch it, man. The only way I can do it, I have to start over. I don't want to start over a board. I know that. Because sometimes when I click on the board, respond to me same time. I don't want to risk that in the class. But it seems like it's disturbing people. Disturbing a lot of people, but that's why I may try to do the thing to the side also. But don't worry yourself. I go work on it. I have to work on it. You see much question upon the board for do? A million. Anyways, I can't take it off, none at all. I can't tell you that. All right, let's go. Let me push it. I'm working out of its way.
Sir, excuse me, sir.
Yes.
He has to just go in press erase and it will erase everything. The
Jerome,
erase
you hear that? Them say go in whatever and press erase.
No, go in the pen.
Go in the pen section.
Move.
Oh.
Go in the pen section and press erase and it will come out.
But Jerome, I'm not sure if you know the name will come up on the screen and never Jerome come up unless you change your name. It was just Rome. R-O-M-E. We did say at the time I mark it. So it's whoever in the class name R-O-M-E. That was the name that I saw. It's not Jerome I saw. Anyways, make we work around it now, people, because me can't take it off. Me can't tell them. Me not take it off long time. All right. So I'm going to write the questions over here. So may I clean up over here, so don't worry about that. May I clean up over this side and do this question over here. All right, give me a minute. All right, so we can work the problem somewhere here. All right. Why Rome, your name just step on the screen again, you know, say you. All right, let's go. Here's the question. It says x squared plus ax plus b is equal to this. Guys, the moment they tell you it's equal to it, it is it. Do it. So they are saying work out the values of a and b. What we are going to do is that we are going to work out the things on the left side, on the right side, should say, and compare it with these. So let us say I have this by itself here. It's my intention to work out this part. So let us take our time and work it out. When you square something, it means you multiply it by itself. So I'm not rushing. So x plus 2 square means x plus 2, and then you have x plus 2 again. Then you have a minus 3. So this is me rewriting this to work it out here. All right, no problem. All right, So let's get into that. At the end of the day, what we want to do is make sure that we remember. I don't know if anybody remember you do these, but this will go with that. Then the x again will go with the 2. This 2 will go with x, and then this 2 will still go with 2 over there. That's what we're going to do now. So x times x will give us x to the second power. X times 2 will give us positive 2x. 2 times x will give me, I'm in the blue now, will give me positive 2x. I just did this. And then 2 times 2 will give me 4. So now x squared plus ax plus b, they're saying it's equal to that. Let us simplify on the left side. X squared plus 4x plus 4. That's what I have. But remember that there was a minus 3 and a minus 3. So I'm going to reduce this 4 minus 3. I'm just going to call it 1 because there was a minus 3 at the back. Here is the deal. X squared plus ax plus b is equal to this. Remember, they want you to find values for a and b. All you have to do is to say, what is beside the x? Look, anything that is beside the x is a, based on what they have over here. Look, a is beside the x. So anything beside the x is a. So you could say, oh, a is equal to 4. Can anybody relate to that?
Yes.
Yes, sir.
And then now, the b is at the back by itself. So you see anything at the back by itself is b. Anything at the back by itself is b. There it is. That's b. So we could say, oh, b equal 1. So this problem that you saw here, sometimes people think it's a biggie. It's not a biggie. The moment you work out regular working out things that you are used to and relax, because equal means same. So then they were indirectly telling you that whatever is on the left side is the same thing on the right side, even if it doesn't look like it at the beginning. It is the same thing. So a is 4 and b is equal to 1. There. Again, you are being encouraged to rewatch the recordings. Anything you're not sure of, we'll come back. All right. All right. So we're on another paper. We're on another question 2 here. Check it out. So for this question 2 here, it says a asterisk b. So this is like a little computer program showing you something. All right. So it says a asterisk b means the square root of a plus 4b. And it is telling you where the positive root is taken. Okay. All right. All right. So this is like extra information where don't stress yourself for. So what we want to do is to find the value of this for them. The value of 1 asterisk 2. Think about this. Wouldn't you agree that a is like number 1 and b is like number 2 right here? The a is at the front, the 1 is at the front. So a is 1. The b is at the back, the 2 is at the back. So b is 2. So what we're going to do is to say that 1 asterisk 2 is going to equal to me substituting things here for 1, because this is a and this is b. So they are saying that a, that means 1, plus 4b, b is 2, and this is equal to 1 plus 8. You know what we're getting? We're getting the square root of 9. And they did say take the positive value, which is just 3. because the square root of any number is two values. It's always a plus and a minus. But they did say where the positive root is taken. That means we're not worrying about the negative one right now. Take it off. So the answer is just positive 3, as you see right here. So basically, you just follow. A is 1, B is 2, and then just substitute and you work it out. You could see this is my A, this is my B. 4 was already there. 4 was in the maths. So you could see we put it together, we get 8 plus 1, we get the root of 9, which is 3, and we're done. So it's not like it's a biggie. We just have to take our time and work through. All right. Question says whether the operation, hold on. Oh, I guess it's the, let me reread. There was a determine. Okay, determine whether the operation denotes by, okay, by the asterisk is commutative. All right, if you don't remember what commutative mean, I'll just advise us. All right, and then I'll tell you the plan of action that we're going to take. When things are commutative, this word that you're looking at, ideas that are commutative are like these. So I'll give you an example rather than try to explain. 2 times 3 gives 6. 3 times 2 gives 6. When things are commutative, you can turn it around and you still get the same result. And not everything can do that. So this is saying that when things multiply, you can turn them around and you get the same answer. That means multiplication is commutative. Sometimes in addition it works, like 3 plus 2, 5. And at the same time, if I had said 2 plus 3, I will still get 5. That means addition is commutative. Now they're asking us if this symbol is commutative. We just did A asterisk B. If this is commutative, then when we do B asterisk A, they should be equal if it is commutative. So we're going to test it now. So now we're going to do B asterisk A. B asterisk A. That's what we have to do now. B asterisk A. All right. All right. Now, let me write back what they started with. Remember, they told us that 1 asterisk 2 is equal to, oh, my bad. Hold on. Hold on. Let me not write there. Let me not write anything in there. Let me take off these. All right. Let me take off these. But I wrote me just spoil up my body, man. All right.
So I know you not come off.
Yeah, man, me no know neither. All right. A asterisk B was said to equal to this. All right, and that we have up there. So A asterisk B is equal to that. So then they are saying that if this is commutative, then we want to turn this around, right? So what you want to turn around now is that we just did 1 asterisk 2. So we're going to do 2 asterisk 1. We're going to turn it around and see if it works. Because if things are commutative, it should give the same result. So we want to answer them. You have to answer them to get the mark. Justify your answer. Your justification is your working out. So watch this. We're going to do 2 asterisk 1. So we're doing it the other way around. So in this case, you could see that 2 is A and B is 1. Things change now. So then we're going to have the square root of, the first one is A, so we put 2 plus 4 times B, but B is 1 this time, 1. I'm already seeing that it's not. So this is 2 plus 4, and this gives us the square root of 6. you can see the square root of 6 is not equal to the square root of 9. Everybody agree? The square root of 6 is not equal to the square root of 9. Whether it's commutative, you could say not commutative. I could tell them that this that you're telling me is not commutative. How did I know? Look at my working. You don't have to say anything else. All you have to do is not commutative, and your working will tell. All of this that you work out here, all of this, and then showing them that this is what I got, but this is what I got the first time, and they're not equal. That is your voice. So when they say justify your answer, your justification is your working out. Done. All right? So it's not commutative, because when we switch around, we did not get the same thing. Pay attention to details as well. Look how many marks I get for this question. A serious question, this. See that? Serious question. It's 3 marks I get to do it. 3. Yep. It's just the fact that a lot of people don't know what commutative means. So again, be advised that just as though I worked out these on the side to explain that when you turn around something and do it, if you get the same answer, it is commutative. And if not, it's not commutative, and that's fine. This is not commutative. Right. Now we're still at number 2. Check out what's going on. Look for yourself. You see that? Look at what they're sending again. We did something like this earlier on. So I just want everybody to start feeling safe and confident in what is coming. Solve the inequality. We solve an inequality already, and we're seeing they're giving it. It's another year. Now we're solving 3 minus 2x greater than 5. I want to say this to you, that when you're solving an inequality, I suggested in the first instance that there is one little thing that is different. Whenever you multiply or divide by a negative number, the sign flip. Whenever you multiply or divide by a negative number, the sign just turn around. That's the only thing. So I believe it's going to happen in this one, and I'm happy so that we are able to see the point I'm making. When we get there, we'll cross it. Watch. We will be working normal. If I'm solving and I need this, I have to leave this alone for now as well. So the intention is that we're going to subtract 3 from both sides. So when you subtract 3, you're left with negative 2x greater than 2. All right? Negative 2x greater than 2. Now, if I am going to divide by negative 2, watch this now. In order to find x, I have to get rid of the negative 2 now. So that means I have to divide by negative 2. And that's why I said whenever you multiply or divide by any negative number, the sign turn around. Look at this one here, and look how it said no. It turns around no. So we divide by negative 2. That's why it shifts around. So negative 2 cancel negative 2. X is less than, the answer is negative 1. So this question is saying that x is less than negative 1. X is less than negative 1. So that's the answer for that. We get 2 marks to execute that sort of thing. Again, the phenomenon here is when you divide by a negative number, the sign turn. And I will advise you as well that when you multiply by a negative number, the sign flip when you're dealing with these type of math. That's the only thing that is different from working ordinarily. Following up on the question. The follow-up question says, represent your answer in above, basically, on the number line. So we want to represent our answer. And I'm glad to show you this. When you're representing your answer on number line, there are 2 ideas. You notice this is 1 mark they're giving because they expect everybody to know that. When you're representing your answer on the number line, you have what is called an open circle that points in the direction that you're talking, or there is a closed circle that points in the direction. Please be advised, when you see the open circle is when they use these, any one of these. And when you see when you're going to close this, like you shade it, is when you're either having the bar underneath it, that way or that way. The moment there's a bar underneath it and you're representing it on the number line, you would have to shade. So if you notice that this one, there was no bar underneath it, which means that I will be using an open circle right there. So then, where am I going to put it? You know, because this says x is less than -1. You're going to go where -1 and do this. And you're not going to shade it. And then you're going to point in this region. Listen to yourself. X is less than -1. Less than. When you're less than something on the number line, you point to the left. That's the answer. X is less than. So you're telling the examiner that the answer is going that way from over -1. So is 1 mark for it. This is what you do to get the 1 mark.
Quick.
You see, when you're really a study and I do your thing, CXC exam easy. It only gets hard when you're out of practice and do your homework. But outside of that, trust me, everything is done quickly. All right, let's probe going further. At number 2, they could do this to you as well. Check it out. This is a C part, and they're giving us some statements. They are giving us some statements. And the statements are as follows. It says 2 tickets, 2 adult tickets, and 3. So we have 2 adult tickets and 3 children tickets cost $43. And then in another situation, 1 adult ticket and 1 ticket for a child costs $18.50. Whenever we're solving simultaneous equations, they have to give 2 situations, of which we have it. They also advise us and they say, let X represent the cost of an adult ticket. So X, my bad. X is my adult ticket. And then Y is the ticket for a child. Yeah. Now let me. All right. Now, let's put this together. Write 2 equations in X and Y to represent 2. All you have to do is to say, okay, 2 adult tickets, say it's 2X plus 3 children ticket plus 3Y. And I had to pay how much? $43 for it. That's 1 mark already. Then 1X, of which I'm just going to say X plus 1Y, and it cost me $18.50. That's the next one. And I get another 1 mark, hence 2 marks. That is all you have to do to get your 2 marks, guys. It's a CXC. And normally I would say CXC easy. So you get 2 marks right there after reading and putting it back. And they told you everything. They tell you what they want you to use for adult ticket and so forth. And then now, watch this. I think it's about 3 marks I might get now. They said solve the equations to determine the cost of an adult ticket. They didn't say to determine the cost of a ticket for a child, just the adult ticket. So if they want the adult ticket, I'm not going to do everything. I'm going to be very, very, very wise. Watch this. 2X plus 3Y is equal to 43. X plus Y is equal to 18.5. Here is the deal. They want the cost for an adult ticket. I am going to eliminate the children. So if I eliminate the children out of the situation, I will be finding the adult ticket same time. So I don't want to eliminate the wrong one and then go have to search for it after. No, I'm going to eliminate what I don't want right now. So watch this. This is, hold on. This is situation 1. This is situation 2. I am going to try to eliminate these. So therefore, the 3's at the top is going to come down the bottom. This is a 1. It's going to go up by the top. Then I'm going to carry out the multiplication to get number 3 and number 4. Watch. So I'm going to color code this for you. I'm going to use number 1 and multiply by everything, including this going across. 1 times 2 is 2x. 1 times 3y is 3y. 1 times 43 is 43. This is the third case. I'm going to change the color here. All right, so I'm using green. So I'm going to use that green to multiply by that, then by that, and then by that. Let's go. So we're talking about, hold on. Thank you. We're talking about, remember you have to verify with me what I'm going. 3 times x is 3x. 3 times 1y is just 3y. 3 times $18.50 will give you $55.50. This is situation 4. Thank you very much. You do notice that I get back the same numbers. And you see the trick I talk about. Anytime you do it, you get back the same number. Now, you can't add this time because if you notice, it's the same sign. I can't add because if I add now, I'll get 6. So guess what? Subtraction have to work now. So I'm going to subtract. So then I'll say 2x right here. So 2x from 3x give us. So I'm going to subtract, okay? Subtract it. So think about it. 2x from the 3x give me just 1x. I'll just call it x. 3y subtract 3y gone. Somebody work out this for me now. Well, I think it is 12.5 anyway, right?
Yes, sir.
55.5 minus 43 will give you 12.5. You know what this means? One adult ticket costs $12.50. That's so we answer question. So you work it out and you find X and then you just tell them, say, listen, the adult ticket where you asked me for is $12.50 it costs. See it there? So this is simultaneous equation in an application way where they set up a real life scenario and you're using it to help yourself. All right. We're going. All right, look again for yourself. Tell me if you're not convinced now. This is a new number 1. As in a new number 2 question. Factorize each of the following. 1 minus 4h to the second. 1 times 1 give me still 1, so 1 is special. And you could see that these are special as well. This is again the difference of 2 squares. All I have to do, look how much mark them I give to do it. 1. I'm telling you, so most times I 1. So then you'll open 2 brackets. That means they are saying it's not a lot of work. 1, 1. Because the square root of 1 is 1. The square root of 4h to the second is going to be 2 with a h. 2 with a h. You put a plus. You put a minus and you get the 1 mark and you're gone. See there? So you're supposed to see by now, you know, the thing works like that. All right, let's jump on this one down here. All right, let me see if I could get it up. All right, no, let me take it now. All right, we're factorizing by grouping because we're looking at 4 terms. Let me write them out for us. We have a p with a q minus a q to the second minus a 3p plus a 3q. Now we have this to factorize. There is nothing straight out in common. So what we're going to do is that we're going to factorize pair by pair. If I can find something in common with these two and something with these two, it can work. And if it can't work, the question wouldn't have been set. Q is the common factor here. So I'll say Q, open a bracket. Q into PQ, we're left with P. Q into minus Q square, we're left with minus Q. Over here, I'm going to have to take out not just 3, but -3. You might ask why. Because I want to ensure that I get my identical twin. If I take out -3 and divide the -3 into -3p, so -3p divided by -3, you will definitely see that -3 cancel -3, leaving positive p. So I have a positive p there. When my -3 goes into my negative, so the -3 into positive 3q, watch. I'm left with a negative and a q, so that's going to give me a -q, which is what I want for my identical twin situation. Whenever I realize that I have that identical twin, then I can just say, okay, I could just write down one of my identical twin. And the things on the outside here, they are, this is one, this is the other. I just place them in the other bracket, q minus 3. And we're done. More than likely, this might be a 2-mark question. So it's for 2 marks right there. Factorization. Remember that the recording is being prepared for you. All right, let's look at that one. It's still under the world of solving. So it says 3/2y is equal to 12. Solve each of the following. When you solve, you're finding an unknown. So right now we want to have the y. But you can see that whenever we have a little denominator thing, we try to get rid of it. So what we're going to do is that we want to get rid of the denominator. So we'll multiply both sides by 2. On the left side, though, this will cancel that. So we have 3y equal 24. Then we'll divide by 3, divide by 3. 3 cancels itself on the left side, but over the right side, 3 into 24, 8. Therefore, y is equal to 8. 1 single mark for that. So they are not, this is just a simple thing. They're saying everybody knows this. All right, now we are pushing it further. We have another thing to solve here. We're not just factorizing here. They want us to solve a quadratic. Let me rewrite it for us. 2x squared plus 5x minus 3 equals 0. So you're looking at that quadratic equation. You can use factorization to solve it. You can use the formula to solve it. I am not going to draw for the formula for 2 marks when I can factorize, meaning a is equal to 2, b is equal to 5, and c is equal to minus 3. AC means a times c. So we want to quickly, hold on, where is my board running to? All right, guys, let me put it back up there. So my AC is going to be my 2 times -3, which is -6. I need to find 2 numbers that can go into -6. And when I multiply them, I get -6. But when I add them, I get 5. So then I'm saying, I know it sounds like it's a 2 and a 3. But what you want to do is you want to list them first. So you want to list the possible things. There they are. So those are the possible things. Here is the deal now. Here is the deal. Look like it's a 1 and a 6. Which one of these can give me a 5? Both of them can give a 5. The problem is that AC is negative. So one of these will be positive and one will be negative. Can't be this. One will be positive and one will be negative. So it's going to be a 1 and a 6. Let the bigger one take any sign D has. Again, D is positive. That means 1 is negative and B is positive. 6 is positive because 5 is positive. So these two numbers will go in the middle. Remember, we're solving. So watch this. You're writing back 2x squared plus 6x minus, you could say 1x if you want, minus 3. And this is equal to 0. Why am I putting back my equal 0? I am not factorizing like they asked me to factorize. I am utilizing the skill of factorization to solve the problem, because we're not really factorizing. We are called to solve, but we are using the factorization as a vehicle to get there. Now, same principle, don't give up. 2x is common, open my bracket. X into 2x squared will give me, 2x into 2x squared will give me x. 2x into 6x will give me 3. Now, you could see that I have positive x and positive 3. When you observe this, start thinking, I need to use -1 to get back my identical twin, -1. So when I take out -1 and I say -1 into -1, I'll get positive x coming down. -1 into -3, I'll get positive 3 coming down, equals 0 still. So I'm keeping my equal 0 because I'm not just doing a regular factorization, I am solving. Now let's organize ourselves. X plus 3. And in the other bracket, we'll have 2x minus 1. And this is equal to 0. We're almost there. Right now, you'll say, how can two things multiply and I get a 0? Because when you have a bracket beside a bracket, it means that the brackets are multiplying. So how you can multiply something and you get a 0? And somebody will say, well, it means that there is a 0 somewhere. Yes, it is. So because we don't know, we're going to say it's either x plus 3 equals 0 or 2x minus 1 equals 0. So we are suggesting that if when you work out this and it's not a 0, then this is a 0. But we're not sure which one, so we have to work out both. So here it is, we're going for both of them. Now, all you have to do with the first one is to subtract 3 from both sides. So you can see that x is -3. So then we're saying when x is -3, that is a solution to that problem up here. There are 2 solutions. So here's the next one. We add 1, we add 1. So if we take our time, we have 2x equal to 1. Divide by 2, divide by 2. X is equal to 1/2. Here is the case. Here it is. X is equal to 1/2. X is equal to -3. So those are the 2 answers from that. Here is the thing that we want to keep and know. How you know how many solutions you get? You can know by looking at this. The highest power of the variable tell you how many solutions you can get if you solve. So I knew that I would get 2 answers because the x, the highest power of the variable, is a 2. So you can keep those in your mind. All right. All right, we have about 11 minutes to go. All right, let's look at this. It says, hold on. All right. And get off the board. It says the quantity F, M, U, V, and T are related according to the formula. There it is. So we're looking at that formula. No problem. Now, the question says, find the value of f. Oh, find the value of f when m is equal to 3, u is equal to that. All we have to do is to substitute. F is equal to, m is outside, m is 3, so I put 3 outside, open the bracket. V is 2, so V right here, so I put 2 there, minus u is minus again. So be careful with these because there is a minus, and then this is minus 1. So don't let it trick you. All over t, and t is 1. Okay. So then what we're looking at is 3 times 3, which is 9. How do I get the 3? Because a negative and this negative will turn this into positive. So you're seeing that it's 3 times 3 over 1, which is 9, because 1 is not changing anything. So it's not a biggie. I don't think there's a lot of mark for that. See that? See how much marks that? 1, because they know that is not a biggie. 1 mark just to do that. All right. The follow-up question now says make V the subject. So making V the subject, making V the subject. So in other words, then the intention is that we're going to transpose so that V is alone. I think I can put it. You can put it right here. So it's F is equal to M open bracket V minus U over T. All right. We want to make V the subject. And you're noticing that V is in a bracket. Not only that, we have a fraction thing here. So what we want to do is to get rid of the fraction like right now. You can get rid of the fraction by multiply both sides by anything under there. It's a T. So I'm multiplying both sides by T. You could see that T cancels itself on the right side. But on the left side, you could say TF or you could say FT. So I'm going to say FT, okay? So FT is equal to M open bracket V minus U. Well, you can do more than one thing here. You know that you can divide by the M. You can distribute the M inside. There are more than one ways. I'm just going to do one. So I'm going to get rid of the M. No, I can divide both sides by M. Divide both sides by M because you could see M cancel M. Bam. So at the end of the day, I have FT over M, and that is equal to, the bracket is not needed anymore because there is nothing surrounding it. So you have V minus U. Now, the last step you can make, think about it, is that you need to add U to both sides. If you add U to both sides, then this you would have, watch this, you will have FT over M. This is by itself. This U is not attached to it. It's just beside it. And this is equal to V because you could see here that a negative U and a positive U gives you 0. So you are left with the V alone, which is equal to all of that. Transposition comes at number 2 a lot. You could see that for yourself. They might give you about 2 marks for that. It was cut off, but it's about 2 marks for it. So you transpose. Again, I'm reminding you, when this recording is posted, please watch it back. Please watch it. Hold on. Okay. Hold on. Okay. All right, we have a couple minutes to leave, about 5 minutes, but I'm not seeing. Hold on. I feel like the board stick for me. Well, we're at the end still. All right, let me go for another paper because the thing is not moving. I could pick off one at the top. One somewhere there. Okay. Oh, all right. I think I know where the papers are, so I don't need that anymore. There they are. Because I knew that I had a lot. I had more than enough. Okay. Okay. All right. So we have a lot of them. All right. You can just do one. See there? Told you. Same thing coming back again on a different vibes and another number line again and more of that again. So it's kind of, so you could see for yourself, this is when this one come, this is a 2016 one, but you could see what's going on. Same type of questions coming back at the places. All right, we have 5 minutes to go. I think we'll be able to do one and then I tell you what I want to tell you and then we go. All right, so we leave in about 5 minutes or less. All right, guys, so don't leave. All right, let's go. Solve for x, where x is real. All right. So as you could see, again, we have inequality here. Looking at it, inequality. So if we're solving, you want to make sure that you have the x's on one side. It's your responsibility. Some people feel nice to keep the x's on the left side. It doesn't matter where you want to keep it. Now, let us say that you want to keep the x's on the left side. Two things are going to happen. This x, this is 5x, is going to have to come across. And the positive 8 would have to somehow reach on that side. So that's the sort of movement that we're going to have to do to gather the x's on one side. Remember the principle, we'll subtract 5x from both sides. But if you don't want to show a lot of working, you could just like say, okay, there is a negative x on that side already. And then this will become minus 5x because you would subtract 5x here and balance by subtracting from the other side. Then we have back our symbol, same symbol, don't change it. You would subtract the 8 from both sides. So you'll end up with a 2 minus 8 on that side. So we would subtract the 5x here. You could see that. You subtract 5x, you know, from both sides. And that's what will happen here. And then when you subtract the 8 from both sides, this is what will happen. Let's simplify. When you simplify this though, you will get negative 6x less than or equal to negative 6 because 2 minus 8 is negative 6. Remember the same principle. You're going to divide again by a negative number. You see, if you realize you're going to divide by a negative number, write another step and turn the sign because you know that you're going to divide by a negative 6. Turn the sign so that you are correct. So now you're seeing that the negative 6 cancel. So we have x is greater than or equal to positive 1. So right now, this is the answer. So much marks to give it to this? 3 marks to get to do this. See there? 3 marks to do it. All right. Then now, in putting it together, they want you to represent that on the number line. Show your answer on the number line. Remember that this one now there is a bar underneath it. So you're going to go where positive 1 is. You draw your circle and you circle it. Remember we said that. Whenever you see the bar underneath it, you do that. And then you are going to point greater than 1 is that direction. All right. Greater than 1. Hold on. Is in that direction and you point. That's it. All right. We'll hang on to that moment now. All right, guys. Just let me say this to you. Let me say this to everybody. We'll stop.